Hello to everybody in this room. My name is Georg Kostner, so I hope you can listen me also in the end of the room. You hear me? And today I will speak about end-user experience monitoring. Alexa is something new we created together with Alan. I will speak about him a little bit later in my presentation. Myself, I'm in the IT field now for 20 years. In the last 6 years, I'm working in the monitoring field. And in this 6 years experience, we provided several services in data center monitoring. And in different projects, there came out often the question, yes, the data center is providing the service, the performance of monitoring system says that the performance is okay, the application is working fine, but the end users are still complaining availability or performance in the reactivity of application. So this was one field that customers or IT managers asks for to solve this issue or to give an answer to the question, how is the experience of the end user in the application in the monitoring field, to address these topics. And the result is now what I'm going to present in the next half an hour. So I hope we can also organize this presentation maybe some interactively. So if there are some questions which during the presentation are raised, please hand up the hands and give me a sign so we can also talk about some questions during the presentation. Few words to the company I'm working on. I'm working in WordPhoenix. WordPhoenix is a company which belongs to the Word Group. We have the headquarters in Italy, Bolzano, and a second branch in Rome. The company is focusing on implementation on ERP system in the Microsoft Dynamics ERP field, also CRM application project within the Word Group and also on the market. Myself in the company are responsible for the infrastructure, system management solution and providing services on the market in this field. The work itself, the headquarters is in Germany, is a huge company where the core business is trading and assembling fasteners. So there are 30,000 sales reps around the world which are selling over 100,000 products on the market. So the WordPhoenix belongs to the Word Group, which is a German group, a German company. And WordPhoenix itself providing services like CRM, ERP, system management solution, system monitoring solution to the Word Group and to the market. So this gives you some idea where I'm coming. We are also providing these services obviously in the monitoring field to our company Word itself, which use SAP. And there are also some experience how we use the engine Alexa to monitor SAP application and to get a feeling how SAP is reacting on end users' performance. Alexa itself is a solution which came from Alan Pipitone, as the name says. He's an Italian guy, he lives in Milan. I met him in 2012. He showed me some prototype in this computer vision area. He's focused on robotics, automation and so on. So this is the field he came from. And he showed with his solutions and prototypes the possibility to automate application from the computer vision, artificial vision point of view, so that a human interaction can, how a human interaction can be simulated on Windows PC or even on Linux or Macintosh. So the idea in this field was to combine his knowledge on computer vision, robotics and so on, and the monitoring field. And on 2012, it started to develop Alexa, the first release. It was a project which we did in Diesel Jeans, so this is a little bit about the history. Diesel Jeans had this question: I need to measure the performance of my user application, and in this case was SAP again, over a Citrix farm in Japan. So they have the headquarters in Italy, but they need to know how fast their Citrix SAP published over Citrix is working in Japan. So the IT manager had some complaint from around the world especially from Japan, that they have also different time zones. And we had to work out a solution to get him the feeling how fast and how availability is the application on the other side of the world. So this was the problem on this area, how to monitor Citrix or terminal server application, but in this case was Citrix from the user perspective. So not to know, okay, Citrix farm is up, CPU, RAM, and all file system and all these stuffs in the data center are working fine, but to have really the knowledge how fast the application is reacting on the user field, on the other side on a client PC, and even if Citrix or directly. And this should work not only for one single application, obviously it should work for several different applications. In that case, one was SAP, the other one was a business intelligence solution built over Hyperion, if I remember well. And another topic which during the years came out from the monitoring field, and this was another scenario on another customer, which had to monitor again SAP, but in this case SAP was outsourced in Telecom Italia in this case, and obviously this company had not the chance to implement some agents in an outsourcing system because Telecom didn't provide him the possibility to install agents, to install a monitoring system in their data center. So, but the customer would like to monitor the availability of the application so that he has numbers, SLA numbers, availability against the telecom provider to measure the services. So not only to trust to the reports which the provider provides to him, but also have the possibility to monitor the application, even if it is deployed over Citrix. So in that case, they looked for a solution how to monitor application. For web application, this is something we already do in a lot of different cases. Maybe somebody of you already used WebInject, Sahi, Selenium, or other solution where you simulate web transaction. So in this case was the idea not to simulate, or the challenge to simulate web transaction, but to simulate real application, even if they are deployed over terminal server Citrix or on a local installation. In this case, there was born the idea to develop something new, to create something which can address this problem or to address this challenge, to make a really monitoring from the end user experience. So not on the data center side, but from the point of view from the end user, and to have the performance figures from the end user. How to achieve this target? To automate the application through the simulation of the user interaction. So it really means to create something which reacts like a user. So if a user moves the mouse around, fills up text fields and so on, clicks on the desktop obviously should be the same as a normal user to simulate on the same desk. So it means that if on this desktop is an antivirus installed, also on this simulated desktop obviously should be installed the antivirus, and the desktop from the performance point of view should be the same. So not on this simulation machine we install, I do not know, 3 gigahertz or quad-core CPU, and the user has only a dual core and has not the same performance. So to create a system which reacts like a user to achieve 2 targets. One is to measure the reliability of the application, the availability, but also to get the performance data. And from the performance data to get the performance data of each single user action. So it means that if he click on OK or fill up a form, click OK, so that each action can be measured and sent back to the monitoring system. So I will show it later how this works and how the figures then in Nagios, for example, are sent back. Another important issue was if these test cases was created to simulate the user interaction, how to create these test cases in a way that they have not rewritten every time the application change. So obviously if the application change is big and a new application is created, also the test cases has to be rewritten, but these automated test cases should not be changed if, for example, the button is on the right side and the application developer moved on the left side. So this system should be able, like a human, he see the button to look around the desktop and able to recognize where the button resides on, and then move the mouse, for example, on this place. The same thing for text fields, menu items, and something like that. So this was a challenge to create these test cases and to create this engine in a way that we have not to rewrite every time if resolution changed, color changed, or something like that, to rewrite the test case by new or to have these efforts. And at the end was the target that this new engine should be also available in an open source form. We was looking around how to achieve this target, and these several technologies which is written down came in the field. Out of it, maybe some of you already knows the possibility to automate application on Windows field with Autoit. OpenCV is an engine which is able to recognize in an artificial way the desktop. So to have an image, I will show you later how this engine, you can imagine how this engine works. Tesseract OCR scanner, which is able, if we have recognized an image where a text is inside, so that we can really have in the application in the test cases then the string itself. So that is able from an image to bring back to the application, to the test case, the string which the user has to put in, or the application brings on the desktop. The first version of Alexa used XML for the definition of the test cases. Then in a second step came in that we need something more powerful, and for that we took the decision to use Python as a scripting language to create, to have the possibility to create simple test cases, but also to extend the test cases in a very powerful way. So this was the result, which more or less in January this year was available and run in a productive environment, like I said before, in Diesel Jeans, in their data center to monitor the SAP application which was published over Citrix. So we have, can imagine that this engine, Alexa, is deployed on a Windows 7, Windows 8, or a Windows Server. In this case was a Windows 7 machine. That's like a normal user in this environment use Windows 7, so the engine is deployed in this environment. And the technology, OpenCV, Tesseract, and all this stuff was embedded or linked in this engine. The test case itself, on the left side, you see it on this slide, or express it in an XML structure. The engine interprets these XML files and execute the application in an automatic way. Get the result or the application works or not works, so that is able to send back to the monitoring system an OK, warning, or critical. And he also recognizes from the interaction from the user the performance data. So each action, the engine is able to say, OK, to move this mouse, to click on OK. The application came back with the data, took 500 milliseconds, for example, to send this data back to the monitoring system. So that with this data, then we can also create some performance graphs with PNP, for example. From the monitoring perspective, so one is to say, okay, application is available, I can start or not. The second one is the user interaction from the performance point of view within the thresholds I provide. So the thresholds in these cases are provided in the engine, so that the engine is able to send back to the monitoring system a warning if a threshold from the performance from the application is over. If I set the threshold, for example, 1 second, and then the test case took 1.5 seconds, is a warning, then I can also define a second threshold on a critical. So if the application took for some test scenarios more than 2 seconds, it sends back to the monitoring system this critical. OpenCV is the technology which is embedded inside Alexa, which is able to recognize the desktop like we do it with the eyes. Alexa engine use OpenCV to make the screenshots of of the desktop of the user in different ways, so that he then can recognize the images, text boxes, and so on the screen. There are only examples how is the way Alexa is seeing the desktop with different colors, with different algorithm to recognize the objects on the desktop. So the engine uses several different algorithms implemented in OpenCV to recognize the objects like we do it with the eyes. So the engine do it in that way, so that, for example, he takes out some color. So if the application changed the color, for the engine change nothing, because he used some algorithm that the color is not anymore so important. After we realized the first test cases, and there was around 20, 25, something like that, there came out some challenge if the test cases are handled in XML files. So XML files is an expressive markup language, but on the other hand, is not a scripting language like Python or some other programming languages. And to handle application exceptions in XML could be a problem. To manage a lot of different XML files and to change then the test case itself could be complex for the guys who has to create these test cases. To create some plugin, for example, to get the data from a test database, which should be used for some test cases, could also be some problem to realize all these kind of things in XML. So there was some drawbacks to use XML. It was the first release, so that we have confidence that the engine is achieving the target, what was to measure the user interaction. But we realized that XML could not be the way to create these kind of test cases. To create also complex and maintain large automated test cases in XML was not the right choice, or was not the way that we would like to proceed. It was also really a problem to handle application exceptions. So if the application for some reason interact in a different way, it was not possible in XML to create this kind of code. So this was another problem, or the third, to create plugins. This is only an example. So every time some extension has to be written, the engine must be provided this in XML markup language, so other one can integrate some new additional functionality. So for these drawbacks, there was the situation to create something new. This was also the feedbacks from Diesel Jeans and from the guys which created the first test cases, that they really run in these kind of problems. Also the complexity to manage these XML files was huge. There are no IDE to create these kind of XML files, so how to write by hand these XML files for test cases took time. So there was clear that something new must come out. This is what now is available, and what the next or the second generation of Alexa was created. One was to find a way to express these test cases in a more powerful way, and the choice was to use Python. So we saw that all the technology, OpenCV, tester for the OCR scanner, and so on, was quite easy to integrate it in Python. Python is a very powerful scripting language, so that everybody with the API provided can extend the functionality of this engine in a way he likes. He can implement test cases, more complex scenarios, how everybody likes in Python, with all the powerful which the programming languages provides, and all these libraries which are around the Python are available. Another step was how to create these kind of test cases. So we need an IDE, an environment to provide to the developers for the test cases, so that they can really manage test cases in an easy way. Obviously, to create an IDE from zero is not an easy stuff. So why to create something new if on the open source field exist already integrated development environments for Python? So in this area Alan took the decision to use Ninja. I do not know if some of you know it or has already used Ninja. It's an integrated development environment for Python, and has the availability to create plugins. So Python with Ninja and Alexa plugins. And here on the left side, you see the icons of the plugins which comes out, which helps then to create these kind of test cases. So that to create really simple test cases to automate application on Windows environment, SAP, Citrix application, you have not to write no code. So this application with the plugin generates the Python code in an automatic way. So you see here the several few of lines of Python code. So it is not necessary to write Python code. This will be generated by the plugin itself if the test cases are easy. But if you need, you have the choice, obviously, then to extend these capabilities and to extend all your test cases with Python itself and to add additional code. How is the architecture for Alexa now built? How is it is composed? OpenCV, as I already explained, analyze and extract all of the information from the desktop. The OCR is the engine which extracts the text itself, so that on the Python code we really can get strings and works with strings. The engine is also able to recognize different buttons, drop-down menus, and all these kind of things in an automatic way. And at the end, there's also the possibility to interact with the application, obviously, to simulate mouse and keyboards. So all these are integrated in the Alexa engine, which from Python APIs can be addressed. And obviously, at the end, we need also the performance data measurement so that we can integrate this also in the test case to send it back to the monitoring system. And was the idea behind on that was really important, that in that case is really the performance from the application when it reacts on the desktop itself, not when the communication on the network is happened and finished, when the information is shown on the application itself. So it means if on the desktop it runs an antivirus and it blocks the desktop in a certain time period during the day, also Alexa will have the same problem as a user will have. And this can be recognized by the IT department. This is the IDE, and there are already available some wizards to create test cases. So on the left side, there are the several buttons to bind an object, to bind text fields, to design keyboard action, mouse events, and so on. So these can all be created without writing bytecode using the IDE, and on the backhand, the IDE is writing the bytecode in the backhand. And for extensibility, you can then also integrate some own Python code for extend the test cases itself, or to use Python libraries to get test data out from other databases or other resources. The toolbar provides all this functionality. So here are there's a list on all these kind of possibility to bind the Windows region, so that if the engine is looking around the desktop, so if you every time give all the desktop that he has to analyze, the performance could be slower for the engine. So if you look on the button on this region on the screen, he will be faster. Obviously, the application changed if the button is moved from the top right to the left. On this case, it will not anymore work. So you have a little bit careful how you define this kind of analysis for the engine. He can also analyze all the desktop every time. Then he took a little bit more time. But you can bind application objects, images, text fields. Very important is that all the action Alexa do is also written in a log file. So if you have to analyze why the application blocked, you will also get a screenshot in that case, so that you can really see what happens if there came out some application errors, so that you can recognize the test case breaks for that case. This log files is created on the desktop where Alexa runs, and on the end he's also able to send by email this screenshot to some email addresses, or keep it on the desktop and look on the log files. At the end, on the bottom you see also the Nagios utilities. This means that in the code you can then generate on which part you would like to get the performance data and the monitoring stuff, so that you can integrate in the test case to say, okay, on this action I will measure the performance, I will set my thresholds for warning and criticals, so that in this case the engine is create this information and then send it back. The engine will normally redeploy it to use the NS client, so that with NS client or executed these test cases, the NS client get back the data from the engine, and Nagios receive the information over the NS client. So this is the way how this data came from the engine back to the Nagios, and then at the end you can create the P&P graphs or some other measurement tools where you would like to integrate this kind of information. So there are some examples how to create test cases with the IDE. So there comes out the cursor so that you can tell to the IDE which kind of region you would like to bind, how to identify objects, to anchor the objects, how, for what texts the engine has to look for, and so on. And the code is at the end generated in an automatic way. So here is an example of the left side. This is a web page on the left side, and below you see if this image is bind with the IDE, which kind of code is generated in an automatic way. There are other examples. Here is another region on the web page. There is a bind of object, and you see the about. So in this case, in this region, the engine is looking for the string about. So there are several ways, and on the web page there are also published now some examples on tutorial how to create these kind of test cases. And together with Alan, we are trying to create more and more examples and tutorials how to create test cases with the engine. So this is what I explained before on this slide, how is executed the test cases. So the monitoring system, you can schedule it in a common way with a with a check, so that you can use a monitoring system whatever you want, and execute the test case with the NS client, which then execute the Alexa engine and send back all this of information. So this is the deployment architecture, and it's very easy. So there are already all stuffs present, so that this kind of scenario can be created and can be deployed on a monitoring environment. This is a project which we did. The application which are monitored in that case are not what are written down here. This is an idea to show you. But on another deployment scenario, there are around over the world all Alexa engines which execute application testing, so that in that case the customer can compare the performance of his centralized Citrix farm from the different countries. So something like that. So there are from here are all the checks from Nagios, and behind every check the performance graphs are generated in an automatic way, and the check is quite simple. So it's in this case the customer asks only to create a very simple test case to make a logon on Citrix on a desktop. So the Citrix farm provides a desktop, make logon and log off. So nothing more. They ask only to be sure that their Citrix farm are working over the world for everybody, and to get the performance data. And you see here also on the same time, on Wednesday at 12 o'clock, there are some differences between the Citrix farms. And this is from the user point of view. So this is how fast Citrix and Alexa was able to connect to the Citrix farm and to get the desktop, and then makes the log off. So you can also see on the performance graph on each test case, open window, login time, click start, click log off, and the log on time. So the entire test case time and each single step will be tracked. And then on for each several farms, there was create several services for Nagios to execute these test cases and to have all these numbers in a central monitoring system, and to get warning and criticals if some thresholds from the performance point of view was not achieved, or Citrix was not reachable for the engine or for the user itself. So this is the scenario. So you can spread around the engine. At present, the engine is only available for Windows environments, Windows 7, Windows 8, Windows server systems, but all the architecture, Python, OpenCV, and all these kind of libraries are also available for Mac OS and for Linux environment. So this engine can also work on a Linux desktop or on a Mac OS. At present, we try to finish for the Microsoft platform because it's one of the most used around the world, but the same engine will also be available then on the other platforms. So to test Citrix farms, for example, you can also imagine to deploy all on Linux, to use, for example, a frame buffer on Linux environment so that you can execute more test cases on a single box. On a Windows, this is not possible, so to scale with test cases, you need more Windows boxes because the application are running itself and they cannot execute on the same time. Otherwise, the engine has a problem to recognize on the screen the correct position. So the only way to scale on Windows is to have more Windows 7 or Windows 2000 Windows servers where you deploy the test cases. On a Linux environment with frame buffers, you can also scale on a single box. Okay. So in this way, we hope and we guess to achieve these benefits so that we are really able to test the reliability and availability of each application, even if the application are deployed or written in Java applets, Adobe Flash, use UNC, terminal server, Citrix, ERP system, and so on. So with this engine, we are able to test and to automate every application, mainframe application, and so on. Collecting performance data for every application and to get the user actions so that you have really a feeling how if the performance of this user action are stable over the 24 hours. Because obviously a user, even if he tests an application, he will not work for 24 hours. Alexa will do, and we have not to pay for him some additional hours. He will work every day and make this kind of tests, and to achieve also the target that the system is so flexible and he can work against changes on the application level. So that not every change on an application means to rewrite the test case or to invest a lot of time in the test cases. I will be honest, obviously if some application change their way to show the data and something, you have to work a little bit on the algorithm to train the engine to use the best algorithm to recognize the objects on the screen. But with some experience, and then the test cases will be really stable and also easy to create. There are a lot of additional ideas how can be the engine new features which are asked to create it more powerful, to create also some more intelligence on the engine. So the list of features or ideas which are still in progress to improve the engine, to improve the way to make this kind of tests are huge. But I think with this first release, we already get very good results on several projects. And I hope also if somebody likes to test it, to use it, to make some experience, will also enjoy to use the present release of Alexa. One idea which came out is also, and this was on the other project because they had a very huge Citrix farm, and they deploy, yes, every week maybe some new application or change the way the application are deployed, so that it's not very useful to create for each application a test case. Maybe there could be create some automatically way to that Alexa can understand which kind of application are deployed over the Citrix farm and can try to connect to Citrix, start the application, see if the application was, if he's able to start the application, close the application, and send back all this information to the monitoring system. So that there is something like a discovery. This can be realized with the Citrix API, so that over the Citrix API, the engine knows which kind of application are deployed, and then can try to start all these kind of applications. So this is a way to see how fast he is able to start the application, and obviously if the application are available for the end user. The idea is every time to put the engine close where the user resides. So Alexa can also obviously deploy it in the data center on a virtual environment, but to get really the feeling if the application are available for the end user, so Alexa should be on the user field. So if the users are on other office far away, so then the engine should be also deployed in that case, so that you really knows the application, the user can start some application over Citrix, over their network, and so on. So that all these kind of layers in an IT infrastructure are also tested. Also to automate more action, to record, for example, this is an idea to record like Sahi do, so that is able to create some interaction and to generate the code how you use the application, so that to write the test cases will be more simple, and also to increase the flexibility. Application errors in some cases should be also improved, because the application in some situation can run in an error, and a user, if he sees some warnings on the screen, click maybe OK and then restart the application or something like that, so that Alexa is also able to handle these kind of errors in a more powerful way. At present, this error handling has to be written by hand. So it means if there in the application can erase some warnings, pop-ups and something like that, in the code must be handled. Otherwise, the engine in this area will be blocked, send back a critical, and you will receive a critical that the application is not working. And also this so that is more powerful in the training of the user interaction, so that the intelligence which the engine has inside will be more and more powerful, so that to write test cases will be more easy. All this information are available also from the webpage, alexamonitoring.com. There is also the download, so that you can download the IDE, execute it, play around, get some first experience. All the code is published on GitHub, so you can also have a look inside the code. The examples, some examples are also published on GitHub. And we are trying to provide some first tutorials for very easy test cases, but to get a first feeling how to create test cases, how to execute it. So we have still a little bit time, so I will try to show you a simple test case.
That is what you mean about having a lot of things in your desktop, right?
Yes. There's some complexity. No. Yeah, parts. So this is the IDE. It's organized in several projects, and there is a very easy test case to execute WordPad, to change the font, to write hello world in the WordPad, and to close the application. So this is quite easy. Test case here is all the code which is generated in Python in an automatic way. So it's nothing more. So let me try to execute it in the hopeless that it works. So in the download area of the web page, in this install sheet is all inside, also the Python environment and so on. So all what you need to try to execute some test cases are inside. So this is the example. Now WordPad is executed. Now Alexa will change the font in the WordPad, write hello world, and close the application. Here you see the outputs of the single steps, all the steps on the single steps, and here you can define the threshold of warning and critical of each step, and to measure to get the warnings and criticals on the single user steps, so that you have also the possibility to say, okay, if the application is not reacting from the performance point of view within a second or within some threshold, so that you really know this. So this is some way to get then on the monitoring system warnings and criticals. One idea which we are also trying to working on, for example, to measure a Citrix latency. So how we can measure from the user point of view Citrix latency is to trying to create a test case from the engine point of view to execute, for example, WordPad or some other application, and to insert simple characters over Citrix, and Alexa is measuring how fast Citrix is displaying these characters back on the application. And to do this with a lot of, so to let work Citrix in a lot of way from the communication point of view, and then measure each feedbacks from the application point of view, and then to write back the latency with some average measurement, standard deviation, and something like that, so that we can try to, in this case, is another approach to try to measure the Citrix latency from the end user and the application point of view, from how the application reacts, and not from the network point of view. So that if you have these metrics and these numbers, you can really have the feeling, okay, the Citrix farm on the other side of the world is really reacting with the latency you expect for the end user. And not with some network tools which are saying, okay, the latency is all fine, but the user are still complaining that he write the code or he writes some text in Outlook or something else, and then he waits for 1-2 seconds, and then he see appearing the texts. So this is something I hear often, and this is a way that we will try to create some latency measurement using this kind of engine. So now the test case was also slower because my antivirus was started. You can see it here. And obviously, I also see that now the test case is running in a slower way. So, this is what we have created and is now available with Alexa. I hope you enjoyed, and there was some useful information, and if there are questions, please. Not too difficult question, please.
Do you think this could be available for Linux?
It is. It is not deployed on the web page because in the first time we was focused more on our Windows platform, but all the engine are also available on Linux, and it could be provided. At present, it's not available, so but it
basically
could be.
The same way that you're using NS client. I mean, with an RPE. Okay. Great.
The same way. So this will not changing. All Python and all the libraries. If you also look on OpenCV, you see also that this project came from a Linux environment. So I told not before because maybe somebody knows C-Coolie. It's an engine similar to Alexa. We saw it that this kind of application exists around the open source field later on. So not when we took the decision to create Alexa. but using the same engine. Also OpenCV, the approach is similar, something we tried to create more simple, because it's very important that the create test cases, the effort to create test cases will not be huge, because otherwise you will have problems during the project. But all the frameworks is available on all platforms. And at present, the install sheet is only available for Windows, because for them you need something.
The thing is, you can write one, let's say, plugin and execute it on both operating systems.
Yeah. At the end, you can also use the IDE on the IDE is a Python IDE, so this will work on Mac, Linux, and Windows as well. The advantage with the Linux could be the frame buffer, because you can create more frame buffers and then you can execute more test cases on different frame buffers, and this will work. On Microsoft, you will never have this possibility. So you need more Windows boxes to scale.
Anyone else? In the download package is all included, the OCR and the...
All, yes.
Okay. And
for OCR is included English, German, and Italian languages. But if you would try to use other languages, then from the webpage, from the tester, you can download other OCR languages. Alan also tried some time ago with Japanese, so to recognize Japanese characters.
And it's possible to extract some informations from the displayed windows and send it back to the monitoring system?
Yes. It is Python, so you have to code it at present. So this is one of the reasons why we took the decision.
Yeah, hey. What I haven't seen, what that came so clear to my mind was at which step is being the Python plugin or the Python tool executed? Is it being done by the NS client
Yes.
and then passively send the information back?
There could be two ways to deploy. One is to design the Nagios checks in an active way. Then NS client execute the engine with the project name and execute the test case. But you could also work in a passive way, so that these test cases are executed from the NS client itself and send only back the information to Nagios like a passive check. So both ways are working fine.
Okay. And you said that, of course, made no sense to execute or to make two test cases at the same time because it would weird the
On the
system.
same box,
On
on different boxes, yes.
Correct. Has Alexa some way to, I would say, to make sure that not already one plugin is being or one test case is being executed? So some kind of, oh, I'm not executing now this check because one is already running?
At present, it will happen some problems if it happens this. So you will see it on the monitoring system. Alexa itself is not checking that, but there's some stuff to improve in this area so that this can be handled in an automatic way.
Okay, so I have take care of that all the
By
test
your
cases
own,
are executed in a specific
So that
time.
what is in this case important, if you schedule the test cases must, if you have more than one test case, they must be sequenced in a sequence way, and you execute one after the other ones. And if the time periods is, for example, 5 minutes, so that the first test cases are finished within these 5 minutes. Otherwise, you will run in a problem.
Okay. Is there some kind of that two checks or two test cases can build on each other? For example, I got one test case opening the application and one test case executing something, and the third test case closing again the application. That, for example, test case 2 is just being executed when test case 1 is active, for example.
In that case, so this is the Python code. So these are the different way, the APIs to interact with the application. So then you can use all the power of Python provides. You can also write classes where you train these classes to say, okay, this is a class. For example, the Citrix log on, log off script. You can integrate this in every other test case how you want. So if you think a little bit like JUnit or Python unit test cases or something like that, if you create something unit test cases way, so tier up, tier down, and all these kind of stuff, you can also create really regression tests and something like that. But then you have to think how to write my test cases, how to organize my test system, like you do it with other unit test case frameworks, and how to create this. This is the power of Python that you can then use to create this. All these things of Alexa or Python code, so with APIs. So then you can model all this how you want. Each is not created in a wizard way from the IDE itself. So then you use the IDE like a normal Python IDE and to organize your code how you want. So this was also one of the reasons why we took the decision to use Python, so that you can really use in your test environments all the power of the Python environment, all the libraries which are around Pythons. Also during the test case to communicate, for example, with another web service, because you will get some data from the web service insert in your test case. All these things can be realized, but you have to write, in this case, Python code.
Thanks.
Welcome.
You said that Alexa is able to detect images also if there was some change in the color or something. Is this something which is enabled by default, or do you have any influence on these values?
Both. Both.
Mm-hmm.
The engine was extended so that he tries different ways to recognize it. Mm-hmm. But with these tolerance values, you can improve the engine that you are more safe to get the information. So there are some values and where to look, how to look, which algorithm to use, so that you will be more in a secure way. Mm-hmm. And for that you need some, you get experience in the way how to use Alexa and how the tutorials are provided. That for this kind of font, maybe these values are better, because it depends also on the fonts. For the OCR scanner, for example, that it works fine, or from the colors that another algorithm is working better with some parameters that other ones. Or for example, if you are with the OCR scanner, we had also the experience that if an image is bringing back text values, for example, I or L, so that you can use, in this case, as a regular expression, or O or 0, if it is if you make some pattern matching or something like that, so that you can also use the regular expression. So if the engine is not really recognizing the correct value, your test case will not break, and you use the regular expression to make it more stable. Mm-hmm. If you can live in this case with this kind of situation.
But these are all features of the OpenCV library? Or
more or less, yes. But they provide a huge amount of way to recognize the visual information. And with Alexa, try to add more information for this topic, for these targets.
Okay. Thanks.
How do you handle the security of the test box when it's installed near the customer, and when there someone type something on the keyboard or move the mouse during the test case? Do you lock the mouse or the keyboard?
This is at the end up of the customer, but it should be locked, the screen. But if somebody is interacting with the desktop, then he can break the test cases. This is true, yes. Alexa is not doing nothing in this area to secure this kind of environment at present.
Okay, you must secure the machine with a registry entry to lock the keyboard or the mouse, and then it's okay. Okay, thank you.
Okay, thank you, Georg.
Thank you, and enjoy.